Hello there, and welcome to Deep Space Sleep. I'm glad you're here. Maybe today felt a little too busy, or a little too bright. Maybe your mind held on to a few things longer than you wanted. Or maybe you've simply been craving a quiet moment, something small and steady to help you unwind. Tonight, this space is yours, a soft doorway into the miniature world that lives beneath leaves, under bark, and in the stillness of the forest floor. A world shaped by tiny footsteps, glossy shells, and the calm rhythm of creatures that move at the pace of breath. Beetles are far more peaceful than we often imagine. Their lives unfold slowly, guided by light, moisture, temperature, and the quiet pulse of the forest around them. Their shells form like layers of crystal. Their wings fold like delicate paper doors. Their movements echo ancient patterns shaped over millions of years. And when you look closely, the world of beetles feels less like insects scurrying through the dark, and more like a gentle ecosystem humming softly, patiently, almost meditatively. In this video, we'll drift through 100 soothing facts about beetles. Not the scary parts, not the unusual or dramatic parts, just the quiet science behind their beauty. You'll hear about iridescent shells glowing beneath morning light, about larvae sleeping inside the safety of warm wood, about tiny legs moving across moss, and the calm, geological time embedded in their evolution. We'll explore the way beetles help forests breathe, how they recycle fallen trees, how they glide through warm air, and how their colors shimmer through microstructures instead of pigments. All of it soft, all of it slow, all of it meant to guide you deeper into rest. As you listen, there's nothing you need to do. No decisions, no tasks, no pressure at all. Let your thoughts settle like dust drifting through a sunbeam. Let your breath ease into the steady rhythm of tiny wings. Let this small world become a quiet place for your mind to rest. If this brings you calm or comfort, you're welcome to subscribe when you wake. But for now, just settle in. Let the forest dim around you. Let the tiny footsteps fade into the distance. And let's drift gently into the peaceful world of beetles together. The gentle armor that reflects morning light begins forming long before a beetle ever reaches the surface of the forest. Inside a quiet chamber of soil or wood, its outer shell grows slowly as layers of chitin harden like cooling amber. This armor isn't just protection. It is a living lens that bends sunlight into soft glimmers. When morning arrives, you can sometimes see a beetle pause beneath a beam of warm light, its shell catching gold the way a still pond catches sky. Tiny grooves and microstructures scatter brightness in gentle patterns, creating a shimmer that looks less like shine and more like breath. And as the beetle moves, the light follows, sliding across its curved back in slow motion. The forest notices without a sound, accepting this small glint as part of its morning rhythm, as natural and unhurried as dew forming on leaves. Quiet footsteps hidden beneath fallen leaves are a kind of forest whisper, too soft for most ears, but steady enough to form their own rhythm. A beetle walks by, lifting each leg in a delicate sequence, guided by instinct and tiny sensory hairs that read the shape of the ground. The fallen leaves cushion every step, folding inward like slow waves around its body. Under this canopy of gentle brown and fading gold, the beetle's movements help turn old plant matter into soil, its motion part of a long cycle that repeats across seasons. The air is cool here, filtered through layers of leaf litter, rich with the scent of earth and time. And as the beetle moves, it leaves almost no trace, just the faint reshaping of small shadows and the quiet rearrangement of particles. Each step becomes part of the forest's soft machinery, a reminder that even the smallest creature contributes to the calm balance beneath the trees. How beetle shells form like slow-grown crystals begins with tiny biological instructions written deep within the insect's tissues. As the larva prepares to transform, chitin molecules arrange themselves into intricate lattices, layer upon layer, the way minerals settle over centuries in caves. The result is a surface that catches light not by pigment alone, but by structure reflecting, bending, and scattering brightness in gentle patterns. When the beetle emerges, its shell is soft at first, pale and almost translucent, like glass cooling after a delicate flame. Over hours, it darkens and hardens as proteins link together and moisture evaporates, leaving behind a protective casing strong enough to endure forest life. In the right light, the shell glows faintly, revealing subtle iridescence shaped by microscopic ridges. It feels less like armor and more like a natural gemstone the forest grew in secret. And as the beetle rests, its new form settles into the quiet rhythm of its surroundings. Ancient beetle lineages drifting through time remind us that forests have long been shaped by creatures far smaller than our eyes usually notice. Beetles appeared more than 280 million years ago, surviving shifts in climate, rising seas, falling continents, and entire ecosystems vanishing into memory. Their bodies changed slowly, guided by the same patient forces that sculpt mountains and carve riverbeds. When you watch a beetle today moving beneath a log or crossing a patch of moss, you're seeing a motion repeated across eras, through warm prehistoric swamps, icy glacial forests, and long-extinct woodlands filled with towering ferns. Their simple, steady movements follow ancient patterns, each step echoing a lineage that has outlived storms, droughts, and the turning of ages. In this continuity, there's something deeply calming. It feels as though time itself softens around them, allowing the present moment to stretch quietly, the way old sunlight lingers on stone long after sunset. The soft click of tiny legs moving across bark is almost musical when you imagine it closely. Beetle legs are built with segmented joints and tiny hooked claws, each joint sliding gently as the insect climbs. When those claws touch bark, they find small grooves and ridges, allowing the beetle to hold on even while moving slowly upward toward light or warmth. The sound, so faint that only stillness makes it noticeable, comes from subtle friction between shell and wood. As the beetle explores the textured surface, it reads the world through vibrations, sensing hardness, moisture, and temperature changes with quiet precision. Bark becomes a landscape of valleys and cliffs, a place where every movement requires intention, but never rush. And as the beetle continues its climb, those nearly silent clicks form a steady pattern, like distant raindrops or a soft metronome guiding its journey through the calm, vertical world of the forest. Colors, shaped by microscopic layers of light, don't behave the way ordinary pigments do. On a beetle's shell, the surface is built from countless thin plates of chitin, arranged like overlapping glass tiles. When light strikes these layers, it bends, bounces, and interferes with itself, creating shimmering hues that shift with every small angle of movement. This is why some beetles glow with greens as soft as moss at dawn, or blues that resemble quiet pools of water resting beneath shade. These colors aren't just decoration. They help the beetle blend into its surroundings by mimicking the forest's natural light. Even in dim environments, the reflections remain gentle, never harsh. And as the beetle moves forward, its shell transforms the faintest rays into a drifting spectrum, almost like a slow ripple of sky following its path. That subtle glow sets the rhythm for the calmer processes within, including the way the beetle breathes. The peaceful rhythm of beetle breathing unfolds in a series of small, steady pulses rather than the rise and fall motion we associate with lungs. Beetles breathe through spiracles, tiny openings along the sides of their bodies that take in air and guide it through branching tubes called tracheae. Inside these networks, oxygen diffuses quietly into tissues without pressure or force. When the beetle is resting, the spiracles open and close in slow intervals, allowing just enough air to flow for the moment. The movement is so gentle that it barely stirs the dust resting on nearby bark. In cool conditions, this rhythm slows even more, creating a calm internal tide that matches the stillness of the forest around it. And as oxygen travels deeper into its body, it fuels the soft work of muscles and wings waiting beneath the elytra wings that stay folded away like sheltered secrets until needed. How elytra protect wings like calm folding doors is a marvel of evolution, shaped by necessity and patience. The elytra, those hardened forewings, act as a shield against rain, predators, and the unpredictable textures of the forest floor. Beneath them lie delicate hindwings, thin as silk and arranged in compact folds. When the beetle rests, the elytra close smoothly, sealing the wings the way shutters close over a quiet window at night. Tiny hinges and membranes allow for this motion, creating a system that opens slowly during flight and closes with equal care when the beetle lands. The hinge mechanics prevent damage from sudden impacts or debris. Even in harsh environments, the wings remain untouched, preserved inside their protective casing. This gentle safeguard encourages long moments of stillness, where the beetle becomes part of the forest backdrop, relying on calm rather than motion to stay safe. Stillness, as a survival strategy in quiet forests, works far better than speed for many beetle species. When danger approaches, perhaps a bird rustling through branches or a lizard moving across soil, the beetle freezes. Muscles lock into place, antennae lower, and the body blends seamlessly into bark, leaf, or shadow. Many predators detect movement more readily than shape, so this temporary stillness becomes a natural shield. Some beetles even mimic the texture of their surroundings, appearing cracked like dry wood or speckled like lichen. During these moments, time seems to slow around them. The forest breeze becomes softer, and light filtering through branches turns still. This silence does not mean inactivity. Inside, the beetle remains alert, sensing subtle tremors in the environment. Those tremors guide its decision on when to resume moving, which leads naturally into the way beetles sense vibrations beneath their tiny feet. The way beetles sense vibrations in the ground reveals an extraordinary awareness hidden inside such small bodies. Their legs are lined with fine sensory hairs and receptors that detect tremors traveling through soil, wood, and leaves. These vibrations carry information about approaching animals, shifting weather, or even the movement of other beetles nearby. Each signal arrives as a soft wave that the beetle interprets through its limbs, sending messages inward along nerve pathways. A distant footstep becomes a muted thump. A falling seed becomes a gentle tick. The movements of earthworms turn into slow, rhythmic pulses. This sensitivity allows beetles to navigate dark spaces, avoid predators, and locate food without needing to see or hear clearly. It is a quiet sense, rooted in touch rather than sound. And as the beetle listens through its legs, the forest becomes a language of subtle motion, guiding it onward with calm precision. Iridescent shells, shimmering without pigment, feel almost magical, yet their beauty is grounded in quiet physics. Instead of relying on chemical colors, these beetles use microscopic layers of chitin that bend and scatter incoming light. Each layer acts like a tiny mirror, reflecting certain wavelengths while letting others slip through. As the beetle moves, the angle of the light changes, creating a shifting rainbow that looks alive on its surface. Greens melt into blues. Blues drift toward violet, all without a single drop of pigment. This shimmering effect helps many species communicate or find mates, but it also gives the forest a sense of moving color, like gentle flashes of sky caught in miniature. And as the beetle walks beneath dappled branches, the glow softens, guiding sunlight into smooth, fluid motion. That drifting light becomes the beginning of the next quiet wonder, the way sunlight glides slowly across their metallic bodies. The slow drift of sunlight along metallic bodies looks almost like water running over stone. When morning light slips through the forest canopy, it travels across a beetle's shell in a gentle slide, lingering on curved surfaces before fading into shadow. The shell's microstructure spreads out brightness in soft gradients, giving the movement of light a calm, liquid feel. As the beetle shifts its position, the reflected glow stretches and contracts, forming smooth arcs that match the rhythm of its steps. In this way, the insect becomes part of the forest's morning choreography. Light, movement, and stillness woven together. Science explains this through surface reflectance, angles, and refractive layers. But the effect feels more like a quiet conversation between the beetle and the sun. These luminous motions help the beetle blend into its surroundings, preparing it for the subtler art of staying hidden through reflected light. Beetles using reflected light to stay hidden rely on a strategy that feels elegant in its simplicity. Their shells mirror the brightness of nearby surfaces, making outlines fade into the soft glow of leaves, bark, or soil. Instead of absorbing color, the shell reflects light outward, scattering it in small patches that resemble forest highlights. A predator searching for clear shapes sees only shifting spots of brightness, not the beetle resting beneath them. This phenomenon, known as diffuse reflection, is a calm, passive method of concealment that costs the beetle no energy. It allows the insect to remain motionless without drawing attention, merging into the soft geometry of its environment. As sunlight moves or clouds pass overhead, the reflections change gently, adjusting without effort. And within those warm, shifting tones lie deeper layers of adaptation tones, shaped by the forest floor itself, where many beetles carry colors drawn directly from the earth. Warm tones of forest floor-colored beetles create a sense of natural harmony that feels almost intentional. Their shells often reflect the browns of fallen leaves, the gentle reds of aging wood, or the muted gold of dry moss. These colors develop through both structural arrangements and subtle pigments stored in the outer layers of the cuticle. Together, they allow the beetle to resemble the world it lives in, giving it a stillness that blends seamlessly into undergrowth. When the insect pauses, it becomes part of the forest's quiet palette, another small stroke of color in the landscape. Tiny flecks mimic soil grains, soft gradients mirror sun-warmed leaf edges. These hues deepen when the air grows humid, preparing the beetle for the more saturated glow that arrives with morning moisture. A gentle shift that leads into the next calm transformation, where dew and humidity draw richer colors from even the simplest shell. How moisture creates deeper hues at dawn comes from the way water subtly changes the shell's surface. When the forest air grows cool overnight, tiny droplets of moisture settle onto the beetle's body, filling microscopic grooves and smoothing out reflective layers. This creates a more uniform surface where light passes through differently, darkening shadows and enhancing warm tones. Colors appear richer, almost polished, as though the beetle has been gently washed in morning light. The moisture also softens harsh reflections, leaving behind a velvety glow that seems to pulse slowly as the insect begins to move. In some species, humidity even shifts the wavelengths being reflected, making greens deeper or reds more pronounced. This dawn transformation doesn't last long, but while it does, the beetle looks like a small ember resting on the forest floor. The moment fades as the sun rises, yet it sets the tone for the rest of the day's quiet interactions. The gentle physics behind structural color begins with how light behaves when it meets the layered surfaces of a beetle's shell. Instead of pigments absorbing wavelengths, thin stacks of chitin plates cause interference. Some wavelengths merge, others cancel out, leaving only certain colors to reach the eye. These layers are spaced so precisely that even tiny shifts in angle create new hues, like turning a gem under soft light. The effect feels alive, as though the shell is quietly breathing color into the air. In motion, these colors blur into smooth gradients that melt into the forest's natural palette. And when shadows fall across the beetle, the structural color adapts instantly, offering another quiet advantage. Its shape blends more fully into the scattered patterns of light and shade that cover the forest floor. Dappled shadows that perfectly fit beetle shapes appear when patches of sunlight drift through branches and break into small, irregular pools of brightness. Beetles often rest right at the edge of these shifting patches, where light is softest and outlines are harder to detect. Their shells, already shaped to reflect or diffuse light, merge into these shadows effortlessly. The forest floor becomes a mosaic of browns, golds, and soft grays, and the beetle's form dissolves into this patterned calm. Science explains it through camouflage and visual disruption, but watching the process feels more like observing quiet harmony, creature and forest, behaving as though they were designed for one another. As shadows drift with passing clouds or swaying leaves, the beetle's shell catches only fragments of those changes, aided by the microscopic surface structures that bend light with delicate precision. Shell microstructures bending light softly rely on intricate arrangements of ridges, grooves, and layers that interact with light on a microscopic level. These features shape brightness into gentle arcs and soften the transitions between light and dark across the beetle's curved body. Instead of crisp reflections, the shell produces diffused glows, as though the light has been filtered through mist. This soft bending of light helps the beetle remain unobtrusive, blending into bark, soil, or leaves without harsh edges that might reveal its presence. The effect becomes clearer when the beetle moves. Light seems to glide across its back rather than bounce sharply. These microstructures also work in low light conditions, guiding faint illumination in subtle patterns that remain visible even at dusk. And as night approaches, these gentle mechanics set the stage for one of nature's quietest secrets, the faint nighttime glow found in certain beetle species. Why some beetles glow faintly in the night comes down to simple chemical reactions wrapped in gentle intention. In dark forests, species like fireflies and glowworm beetles use bioluminescence, produced by the interaction of luciferin and oxygen, catalyzed by enzymes called luciferases. The light is cool, soft, and efficient, giving off no heat. This glow serves many purposes: attracting mates, signaling to other beetles, or deterring predators with a gentle reminder that they may be unpalatable. The faint radiance hovers just above the forest floor, sometimes no brighter than a distant star, yet enough to create tiny pockets of illumination that guide nearby insects. When the glow flickers through dew or mist, it forms small halos that soften the surrounding darkness. This silent light opens the doorway to deeper bioluminescent wonders found in the calm science behind beetles that glow intentionally, not just faintly. The calm science of bioluminescent beetles reveals a harmony between chemistry and behavior. The glow they produce results from a controlled reaction inside specialized light organs, where luciferin, oxygen, ATP, and luciferase combine to create a steady, cool light. Unlike flame or heat-based reactions, this illumination is gentle, efficient, and sustainable, allowing the beetle to communicate without draining energy quickly. In quiet nighttime forests, these glows pulse softly, forming rhythms that feel almost like breathing patterns. Some species coordinate flashes, creating sweeping waves of light that drift over meadows or woodland edges. Others maintain a constant, low glow, illuminating the moss or leaf litter beneath them. Science explains these displays through chemical pathways and evolutionary advantages, but the result feels more like a serene language spoken through brightness. Each faint pulse adds a sigh of light to the night, completing the story of how beetles use the softest glow to be seen. Beetles turning fallen wood back into soil play a quiet but essential role in forest renewal. When a tree falls, its dense fibers begin a long journey of breaking down, and beetles are among the first caretakers to arrive. Species like bark beetles and wood borers chew through layers of dead wood, grinding fibers into fine particles that other organisms can use. Their mandibles shape pathways where fungi and microbes soon follow, speeding decomposition in ways that blend into the forest's natural rhythm. As beetles move through the wood, they leave behind small chambers that trap moisture, allowing decay to continue even during dry days. The result is soil enriched with nutrients, ready to nourish seedlings or moss. This transformation unfolds slowly, quietly, and with remarkable patience, setting the stage for the deeper processes that take place beneath logs, where decomposition forms a soft dance of life and decay. The slow decomposition dance under logs begins when fallen wood becomes a shelter for dozens of species working in delicate sequence. Beetles carve openings that allow air and moisture to enter, creating patches of softness inside the once solid trunk. Fungi thread through these tunnels, turning wood into spongy networks of fibers. Microbes join in, breaking cellulose and lignin into simpler compounds. As seasons pass, the interior of the log shifts from firm to crumbly, from dark to rich brown, from lifeless to quietly alive. Beetles wander through these changing textures, drawn to the slightly warmer, slightly moister microclimate inside. Their movements further mix the softened material, helping decomposition progress evenly. This ongoing dance, slow, rhythmic, and nearly invisible, creates the perfect habitat for species that spend years hidden inside trees, resting in shadows shaped by generations of wood-eating insects. Species that sleep inside trees for years take advantage of the forest's most stable shelters. Many longhorn beetles and wood-boring species spend much of their lives as larvae within thick trunks, cocooned in darkness and steady temperature. Here, the world becomes a quiet chamber filled with the faint scent of resin and the soft vibrations of distant movement. Growth happens slowly, fueled by nutrients extracted from the surrounding wood. Some larvae remain inside for multiple seasons, waiting for the right combination of moisture, warmth, and internal energy to transform. When they finally emerge, their exit holes mark the end of a long, hidden journey. Their presence deepens the forest's tapestry of life, and their patience mirrors the slow pace of decomposition unfolding just outside their chambers. These larvae carve the tunnels that shape the next stage of the forest cycle, creating pathways for those that follow. How larvae create quiet tunnels beneath bark begins with their instinctive drive to feed and shelter. After hatching, tiny beetle larvae burrow into the inner bark, where nutrients flow in channels that once carried water and sap. Their mandibles scrape through soft layers, forming winding patterns known as galleries. These tunnels grow steadily, often in graceful arcs that map the larvae's growth over time. The design isn't random. Larvae avoid dense knots and dry areas, seeking moisture-rich pockets where bark peels easily. As they tunnel, they leave fine sawdust that settles into still corners of the tree, providing material for fungi and microbes to colonize. These hidden pathways expand with each passing day, offering protection from predators and temperature shifts. And through their slow carving, they help define the scent and soil textures around them. Textures that contribute to the earthy smell rising from beetle-shaped ecosystems across the forest floor. The earthy smell of beetle-shaped ecosystems comes from a blend of decaying wood, fungal growth, and the subtle chemistry of beetle activity. When beetles and larvae break down fallen branches or burrow beneath bark, they expose new surfaces where microbes release compounds known as geosmin and other soil-rich aromas. These scents drift upward in warm pockets of air, creating that familiar fragrance we associate with healthy forests. The smell deepens as wood softens, as moisture gathers in shaded hollows, and as beetles continue to reshape fibers into finer material. Each movement they make contributes to this aroma, sawdust mixing with humid air, fungal threads unlocking hidden notes of earth. Walking near these microhabitats, you can sense the forest's renewal through its smell alone. And as this fragrance settles, it invites you deeper into the next quiet chapter of the beetle's hidden world, where decomposition and life remain softly intertwined. Moss, fungi, and beetles sharing one breath create a tiny ecosystem where every element nourishes the others in quiet harmony. Moss gathers moisture from misty air, holding it like a soft sponge across stones and fallen logs. Fungi thread through this dampness, extending pale filaments that break down wood and release nutrients. Beetles move between these elements, carrying spores on their shells, loosening soil with their steps, and stirring pockets of humidity that help spores settle. Together, these three form a living triangle of exchange: moisture, decay, renewal. Even the air they share becomes richer with each interaction. The moss cools it, the fungi scent it, and the beetles keep it moving. This shared breath deepens as seasons shift, guiding beetles into the slow rhythm of the forest, where each change in temperature or light becomes a subtle signal they learn to follow. Beetles, following seasonal forest rhythms, respond not just to temperature changes, but to the texture of air, the softness of light, and the moisture held in soil. In spring, warm breezes stir them from hiding, encouraging movement toward fresh bark or new growth. Summer brings long, sunlit days that warm their shells and speed metabolism, allowing them to forage more deeply into the forest floor. When autumn arrives, cooler winds slow their steps, pushing many species toward sheltered logs, moss beds, or the undersides of stones. Winter's arrival brings a near-complete stillness, where only subtle vibrations and faint light shifts guide their choices. These rhythms shape every stage of their life cycle, tuning each phase to the forest's broader pulse, one that becomes even more apparent in how their lives adjust to warm and cold winds. Life cycles tuned to warm and cold winds reveal how deeply beetles depend on small environmental cues. Rising temperatures stimulate feeding, growth, and metamorphosis, while cooler air pulls them into rest, conserving energy for months at a time. Each gust of wind carries information: warmth, hinting at new food sources; cold, warning of leaner days ahead. Beetles sense these changes through thermal receptors on their bodies, tiny structures that read fluctuations with impressive accuracy. A warm breeze might nudge a larva to continue feeding. A cold front might signal the need to burrow deeper for safety. These wind-guided rhythms shape the timing of every transformation the beetle undergoes, especially the long, patient transition from larva into adult, an internal process shaped by temperature, timing, and instinct. The patient transformation from larva to adult unfolds entirely in darkness. Inside a concealed chamber carved from wood or soil, the larva stops feeding and begins reorganizing its body. Soft tissues shift, old structures dissolve, and new ones form. Wings, legs, antennae, and the hardened plates of an adult shell. This metamorphosis is powered by stored energy gathered over months or years. It proceeds in slow, steady stages, each guided by hormonal changes and the surrounding temperature. Even though the process is hidden, the forest still influences it. Warm days quicken development. Cool nights slow it to a gentle crawl. When the transformation completes, the adult beetle rests in a state of deep stillness, preparing for emergence. This stillness mirrors the next quiet stage, where the new form waits beneath soft soil in a pupation chamber touched only by silence. The stillness of pupation beneath soft soil is one of the forest's most peaceful mysteries. Here, the beetle rests inside a compact, protective space shaped from earth or decaying wood. The soil around it insulates against temperature change, muffles sound, and filters moisture in a steady, comforting gradient. No movement escapes the chamber's walls. Even the smallest shift is absorbed by the soft, surrounding earth. Inside, the pupa remains motionless, suspended in a delicate state where every cell finalizes the structure of the adult body. The calm is so complete it feels like the forest is holding its breath. Microbes move quietly in the nearby soil, moss dampens footsteps overhead, and distant vibrations fade into a low hum. When the beetle finally emerges, it does so slowly, breaking the chamber's surface with patient intention, carrying forward the soft, enduring quiet of its hidden transformation. Wings folded like delicate paper beneath armor remain one of the forest's quietest marvels. Hidden under the beetle's hardened elytra, these membranous wings rest in intricate pleats, arranged with the precision of tiny engineered fans. The folds allow large surfaces to compress into a compact space, protected from the bumps, moisture, and rough textures the beetle encounters while walking. When the beetle prepares for flight, its body lifts gently, and the elytra rise like slow opening doors. The wings unfurl in soft, fluid motions, stretching outward as light filters through their translucent edges. Air gathers beneath them, ready to support the beetle's rising weight. Despite their fragile appearance, these wings generate powerful lift through rapid strokes, each movement shaped by balance and patience rather than speed. And as the wings extend fully, they prepare the beetle for the next calm moment. A slow, steady takeoff carried upward by morning air. Slow, steady takeoffs in morning air reveal the beetle's patient approach to flight. Instead of launching abruptly, the beetle begins by raising its elytra and unfolding its wings, allowing them to catch the cool, dense air of early day. Each wing beat is deliberate, measured in tempo and force, creating lift through smooth, downward strokes. Morning air offers stability because lower temperatures slow thermal turbulence, giving the beetle a calm, predictable environment to rise. As sunlight filters through the forest canopy, it lands softly on the wings, illuminating their membranes in pale gold. The beetle drifts upward gradually, its body aligned with subtle air currents rather than fighting them. Every motion feels intentional, guided by instinct and evolving rhythms of the forest. And once the beetle clears the surrounding leaves, the gentle ascent transitions into the soft hum of flight, drifting through forest openings, marking the next phase of its airborne journey. The soft hum of flight through forest openings is a sound built from gentle vibrations rather than force. As the beetle's wings beat rapidly, they disturb the surrounding air in smooth, rhythmic pulses, creating a hum that resembles a whisper carried across leaves. These openings in the canopy act like natural amplifiers, shaping the sound as it moves through warm pockets of rising air and cooler layers hidden in shade. The beetle's path weaves between beams of sunlight, each shift altering the tone of the hum slightly, as if the forest is tuning it. This quiet resonance helps the beetle sense open space and maintain stability while navigating small gaps. The hum is never loud. It is soft enough to blend into the background breath of the forest itself. And beneath that subtle vibration lies the delicate network of supporting structures, veins within the wings that guide and manage air with remarkable precision. How beetle wings are supported by quiet veins becomes clear only when one looks closely at their structure. Each wing contains a branching lattice of veins that reinforce the thin membrane, creating strength without sacrificing flexibility. These veins guide hemolymph during expansion, inflating the wing to full size before it stiffens for flight. Once airborne, the veins channel airflow, controlling subtle shifts in pressure that keep the beetle stable. Different species show unique vein patterns shaped by habitats. Thicker veins for stronger strokes, finer networks for smoother gliding. The veins also carry sensory information, helping the beetle respond instantly to changes in air movement. Their arrangement resembles tiny architectural beams, supporting every gentle motion. And as the beetle moves through open air, these veins allow the wings to act like miniature gliders, leading naturally into the soft aerodynamics that help such a small creature drift so gracefully through the forest. The aerodynamics of a tiny glider like a beetle are shaped by wing curvature, air pressure, and rhythmic motion. Each wing beat pushes air downward, creating lift while forming a low pressure zone above the wing. This differential allows the beetle to rise despite its modest size. The curved membranes guide airflow smoothly, minimizing turbulence and conserving energy. Even the rigid elytra assist by stabilizing the body like small, protective fins. As the beetle flies, subtle adjustments in wing angle help it navigate shifting air pockets, whether warm currents rising from sunlit leaves or cooler drafts drifting through shaded spaces. The beetle's flight appears simple, yet each movement reflects a complex balance of structure and airflow. Between wing beats, the beetle may glide in brief, weightless moments, drifting like a tiny leaf carried on wind. These glides demonstrate how aerodynamics enable calm, controlled motion, bridging gently into the next mysteries of flight. Beetles drifting with warm, rising air often appear weightless, as though the forest itself is lifting them. When sunlight warms the ground, pockets of heated air begin to rise in slow columns called thermals. Beetles sense these gentle updrafts through their wings and body hairs, allowing them to glide upward with almost no effort. Instead of beating their wings rapidly, they open them wide and let the rising air carry their bodies into higher layers of the forest canopy. Their movements become smooth and buoyant, guided by the invisible warmth drifting from soil, leaves, and bark. This effortless lift saves energy and helps beetles travel farther than they could through wing beats alone. As they ascend, the world below softens into patterns of shadow and light. And within this upward drift, sunlight eventually touches their wings, creating another quiet transformation mid-air, shimmering that glows softly as the beetles float across open forest air. Mid-air shimmering from sun-touching wings happens when light catches the thin membranes at just the right angle. Beetle wings are translucent and finely textured, filled with microscopic ridges that scatter sunlight into soft, radiant patterns. As the beetle drifts or glides, these patterns shift constantly, turning each wing beat into a flicker of gold, amber, or faint silver. The shimmer is not bright or sharp, it behaves like sunlight glancing off rippling water, gentle and fleeting. Forest openings amplify this effect, allowing uninterrupted beams of light to meet the wings and break into delicate sparkles. The beetle itself may not notice the shimmer, but nearby leaves glow with the reflected brightness. This luminous dance marks the beetle's passage through warm, open air and leads naturally into moments where some species slow their flight entirely, entering a state of calm hovering that feels almost motionless above flowers. The calm hovering of flower beetles is a quiet demonstration of balance and control. These beetles position themselves above blossoms by adjusting wing angles in small, precise increments, creating lift without rising or falling. Hovering allows them to feed on pollen, nectar, or soft plant tissue while staying airborne, safe from predators on the ground. Their wings move quickly but smoothly, generating a faint hum that blends into the background buzz of forest life. The hovering motion resembles a tiny suspension in time, neither forward nor backward, simply present in the air. This stillness helps them inspect flowers, sense chemical cues, and choose the best landing spots. The air around them shimmers gently from the wing vibrations, creating a halo-like blur. When the hovering ends, the beetle re-enters the forest's larger wind patterns, guided by soft currents that carry them into broader spaces, shaped by the motion of air itself. Wind-guided movements through calm spaces allow beetles to glide longer distances using minimal energy. As they fly, sensory hairs on their legs and antennae detect subtle shifts in airflow, helping them find the smoothest, quietest paths through the forest. These pathways are shaped by branches, leaves, and temperature gradients, creating corridors of soft wind that funnel gently between trees. A beetle riding these currents can drift like a small, living seed, adjusting its wings to match the pressure and flow around it. Some winds lift them higher. Others guide them sideways into new pockets of sunlight or shade. The forest becomes a map of invisible rivers, each one carrying different scents, temperatures, and signals. And as the beetle follows these currents, the journey eventually slows as the day cools, preparing the insect for the final stage of its flight. Wings resting and cooling in late evening air. Resting wings cooling in late evening air brings a sense of closure to a beetle's day. After hours of flight, the wings, thin, warm, and flexible, need time to release the heat gathered from constant movement and sun. Evening air, cooler and heavier with moisture, settles around the beetle as it folds its wings beneath the protective elytra. Tiny temperature receptors along the wing edges sense the change, helping muscles relax. The forest quiets during this hour. Shadows lengthen, sounds soften, and the air grows still enough for the beetle to rest undisturbed. With wings tucked safely away, the beetle's body cools evenly, allowing energy to be conserved for the next day's movement. This cooling period strengthens the wing membranes, restoring their flexibility, and in the slowing light of dusk, the beetle becomes motionless, merging with the calm atmosphere around it, like a small, patient ember settling into darkness. Beetles gently pollinating quiet flowers create some of the forest's most delicate interactions. Many beetle species visit blossoms not for their beauty but for nourishment, feeding on pollen, nectar, or soft petals. As they move slowly across each bloom, pollen grains cling to the textured surfaces of their bodies, especially the fine hairs along their legs and undersides. When the beetle departs, it carries these grains to the next flower it encounters, completing a natural exchange that has existed for millions of years. Beetle pollination is unhurried compared to bees. Their movements are slower, their landings heavier, their pathways more meandering. Yet this gentle pace allows them to visit the interior of deep blossoms that other pollinators avoid. Their pollinating steps create ripples in the forest's reproductive cycle. And as they continue exploring, their interactions expand into deeper relationships, some involving fungi woven through soil and wood, The subtle exchange between beetles and fungi unfolds in dim, sheltered places where moisture lingers. Beetles often carry fungal spores on their shells, transporting them to fresh patches of wood or bark. In return, fungi soften and break down tough plant material, creating food-rich environments for beetle larvae. This partnership, though quiet, shapes entire decomposer networks. Fungal threads travel through wood like pale roots, while beetles carve small tunnels that increase airflow and humidity inside logs. Together, they transform dead material into soil-building fragments. Some beetles even rely on specific fungi for survival, cultivating them inside their galleries. These relationships blur the lines between individual species, merging them into a shared ecosystem. And from this cooperative foundation rises the lush growth of mosses that cover logs and stones, forming cushions where beetles often rest. Moss cushions, offering safe resting spaces, provide beetles with shelter that is cool, humid, and softly textured. Moss absorbs water from mist and rainfall, holding it within tiny leaves that form dense mats over soil and wood. For beetles, these cushions regulate temperature, slow evaporation, and offer protection from predators. The springy structure supports their weight without disturbing the forest floor, allowing them to hide in ridges of green that resemble miniature forests. Moss also hosts tiny invertebrates and microbes, creating a microhabitat rich in scents and signals. When beetles settle into these cushions, they pause long enough to gather environmental information. From here, they pick up faint chemical traces, drifting through the air scent trails that will guide their next movements with surprising accuracy. How beetles navigate by scent trails begins with their ability to detect chemical cues through sensory receptors on their antennae. These receptors identify pheromones, plant odors, fungal compounds, and even the faint smell of decaying wood. As the beetle moves, its antennae sweep the air like soft, flexible probes, sampling tiny molecules that mark pathways to food, mates, or shelter. Some trails linger for days. Others fade with sunlight or humidity. Beetles interpret these gradients by turning towards stronger concentrations or pausing when signals weaken. The process is calm, methodical, and instinctive. Navigation by scent helps beetles move through cluttered environments where vision is limited. And these journeys often lead them into encounters with other forest residents, particularly ants, with whom beetles share peaceful coexistence zones shaped by mutual benefit. Ant and beetle peaceful coexistence zones form where resources are abundant and conflict offers no advantage. Some beetles mimic ant scents to blend into colonies, avoiding detection while feeding on waste or fungi. Others simply share the same territory, respecting the ant's pathways and moving slowly to avoid triggering defensive behavior. Ant nests create stable microclimates, warm, moist, and rich in decomposing material, which attract beetles seeking shelter or food. In return, beetles help clean debris or disperse fungal spores that benefit the colony. These quiet collaborations occur beneath logs, inside leaf litter, and along hidden soil chambers. The forest becomes a layered network of cooperation rather than competition. And from these shared spaces, the beetle continues its journey into ever deeper interactions within the calm rhythms of the woodland world. Quiet hunting moments of ground beetles unfold close to the soil, where shadows gather and sounds soften. Ground beetles are swift predators, but their approach begins in stillness. They pause beneath leaves or stones, sensing vibrations through the earth and reading faint chemical cues drifting in the air. Their legs remain poised, antennae slightly lifted, bodies aligned with the forest floor. When prey approaches, often a small insect or soft-bodied larva, the beetle moves with sudden but controlled precision. Its mandibles act like tiny pincers, securing the meal before it slips away. Despite their speed, these beetles hunt without chaos, blending silence and intention. Their presence influences nearby microhabitats, shaping insect populations and contributing to soil health. After feeding, they retreat into dimmer areas, resuming their steady exploration of the forest floor. And as they wander, their paths sometimes cross with others of their kind, creating moments that resemble a slow, deliberate dance. The slow meeting dance of two beetles is a ritual shaped by scent, posture, and patience. When two individuals encounter each other, they rarely rush forward. Instead, they circle gently, tapping antennae against one another to read chemical signals. These taps reveal species identity, sex, and even readiness for mating. The movement is unhurried, like a small performance within the quiet undergrowth. They mirror each other's steps, shifting weight, raising elytra slightly, or pausing to sense subtle changes in air pressure. Sometimes, the dance ends with one beetle moving on. Other times, it leads to closer interaction. This delicate choreography prevents unnecessary conflict and ensures compatibility before continuing. Once the meeting concludes, each beetle resumes its path, often guided by a deeper instinct, one that draws them toward the soft, irresistible scent of decaying wood drifting through the forest. Beetles, following the whisper of decaying wood, are responding to chemical hints released as wood fibers break down. Fungi, bacteria, and moisture all contribute to the scent profile that beckons wood-feeding beetles or those seeking shelter. These beetles detect compounds, such as terpenes and alcohols, through their antennae, allowing them to locate suitable logs from impressive distances. The scent grows stronger as they approach, guiding them through shafts of light and pockets of shade. Decaying wood offers protection, food, and stable humidity, creating an ideal refuge. Beetles enter through tiny cracks or chew their own openings, slipping into the soft interior where threads of fungus glow faintly in the dimness. Inside these fading structures, life thrives quietly. And when these beetles emerge again, they often wander near still puddles where their silhouettes reflect softly on the water's surface. Still puddles reflecting beetle silhouettes capture peaceful snapshots of movement and pause. When a beetle approaches a puddle, the water's surface reacts like a mirror stretched thin across the forest floor. The beetle's outline appears crisp, doubling each small motion. Sunlight drifting through branches touches the reflection, adding warm tones to the image. Puddles also serve as important hydration sources, drawing beetles to drink from their edges. As they lean forward, ripples distort their reflection, creating gentle waves that widen slowly before fading back into perfect stillness. The moisture rising from the puddle cools their bodies, offering relief after long periods of walking or flight. These quiet drinking moments deepen the connection between beetle and habitat, and when the beetle resumes feeding, the forest fills with another subtle sound, the delicate whisper of mandibles working softly. The delicate sound of beetles feeding is easily missed unless one listens with attention. Their mandibles scrape, nibble, or pierce depending on the food they seek: soft plant tissue, fungi, pollen, or decaying wood. These movements create faint clicks and rasps, blending into the natural hush of the forest floor. Each species produces a slightly different feeding rhythm, shaped by jaw structure and diet. As beetles feed, they help break down organic matter, aiding nutrient cycling in ways far larger than their size suggests. The sound is calming, a tiny heartbeat within the ecosystem's broader pulse. It echoes softly between leaves, drifting like a quiet thread of activity woven through still air. And as the beetle continues nourishing itself, the gentle pattern of its feeding sets the stage for the next chapter of its life among the deeper cycles of the forest. Beetles surviving multiple extinction events shows how deeply their lineage is woven into Earth's history. Long before mammals emerged, beetles had already established themselves in ancient forests, wetlands, and shifting coastlines. Their compact bodies, efficient respiratory systems, and adaptable diets allowed them to endure catastrophic changes that erased countless other species. Volcanic winters, collapsing ecosystems, and fluctuating climates reshaped the planet again and again, yet beetles continued in quiet persistence. Many survived by retreating into soil, bark, or fallen logs, where temperature and moisture remained stable enough to support life. Others shifted their feeding habits or expanded into new habitats as old ones disappeared. Each survival shaped their evolution, building a legacy of resilience that remains today. And from these survivors came the beetles whose wings now shimmer across modern forests, some bearing fossil-like patterns that echo their distant ancestors, preserved in stone like stained glass windows into the past. Fossil wings preserved like stained glass reveal how ancient beetles once shimmered under prehistoric light. When insects became trapped in sediment, fine mineral particles replaced their tissues, preserving delicate wing structures in remarkable detail. The resulting fossils display faint, iridescent patterns, greens, blues, and golds that still catch the eye millions of years later. These colors are not pigments, but impressions of structural layers that bent light long before humans ever witnessed them. Holding such fossils is like glimpsing a moment frozen in deep time, a memory of ancient forests and warm, humid air drifting through vast fern canopies. Some fossils show veins so clear they resemble tiny brushstrokes across translucent stone. These preserved wings remind us that beetles once thrived in ecosystems far older than modern woodlands, filling the world with movement and color. Their presence hints at the forests they once inhabited, lush places crowded with early beetle life. Ancient forests filled with early beetle life were vibrant, humid worlds teeming with slow, steady movement. Towering ferns and primitive conifers created dense shadows where beetles explored bark, soil, and fallen fronds. Their bodies were simpler than today's species, but their roles were already essential, breaking down plant matter, feeding on fungi, and helping cycle nutrients through thick layers of decaying vegetation. Warm air drifted beneath tree canopies, carrying scents of sap and damp wood. In this world, beetles scurried across enormous roots, climbed oversized seed cones, and tunneled into soft, waterlogged logs. Fossil evidence shows these early beetles interacted closely with the plants around them, shaping soil patterns that persisted for ages. As climates changed and forests evolved, many beetle traits remained steady, forming the foundation for adaptations unchanged for millions of years. Adaptations unchanged for millions of years demonstrate the success of beetle design. Their hardened shells, segmented legs, and efficient tracheal breathing system function so effectively that evolution has rarely needed to alter them. Some species today look nearly identical to their fossil ancestors, sharing the same body outlines and structural features. These long-lasting traits include the ability to conserve moisture, hide beneath protective surfaces, and consume a wide range of food sources. Even their reproductive strategies, laying eggs in sheltered places and allowing larvae to feed on stable materials, have persisted across epochs. This continuity reflects a biological blueprint perfectly suited to shifting environments. As forests rose and fell, climates warmed and cooled, and continents drifted apart, beetles carried these ancient tools forward. Their bodies became records of geological time, shaped slowly by the pressures of Earth's changing landscapes, just as their shells grew hard and enduring through millennia. Hard shells, shaped by geological time, show how deeply beetles are influenced by the environments they inhabit. These shells, made primarily of chitin reinforced with proteins and minerals, evolved layer by layer, to resist pressure, moisture, and predation. Over millions of years, beetles living in arid regions developed thicker, more protective exoskeletons, while species in humid forests retained flexible, lightweight forms. Each shell carries hints of ancient climate's patterns that formed in response to temperature shifts, rainfall, and soil composition. The colors, too, reflect these influences, shaped by structural arrangements that developed as geological forces sculpted mountains, dried lakes, or flooded plains. When we observe a beetle's shell today, we see more than protection. We see a map of environments long vanished. And as these shells glint under forest light, they connect the present moment with a lineage that has endured every chapter of Earth's shifting terrain. The slow evolution of beetle senses reflects millions of years of refinement shaped by quiet environments. Early beetles relied heavily on simple tactile cues, sensing vibrations through their legs and reading faint shifts in air pressure. Over time, their antennae became more sophisticated, developing thousands of microscopic receptors capable of detecting pheromones, plant chemicals, humidity, and even subtle temperature gradients. Vision evolved more slowly, with many species favoring low light sensitivity over sharp detail, allowing them to navigate dawn, dusk, and the dim interiors of logs. These gradual changes were never rushed. They unfolded in forests where patience offered more advantage than speed. As ecosystems shifted and climates changed, beetle senses adjusted gently, becoming tuned to the rhythms of soil, bark, and falling leaves. These refined senses contributed to their survival across ages, explaining why beetles became some of the planet's quietest, most enduring survivors. Why beetles are the planet's quiet survivors lies in their ability to persist through upheaval with minimal demands on the world around them. Their bodies are compact and efficient, requiring little energy to maintain. Their diets are flexible, ranging from decaying wood and fungi to pollen, stored seeds, and small prey. Beetles occupy niches that are stable even during environmental change beneath bark, inside soil, under stones, or in the hollows of dead trees. Their life cycles are adaptable, capable of slowing during harsh conditions and accelerating when resources return. They do not rely on speed, strength, or dominance. Instead, they depend on silence, shelter, and steady rhythms. When landscapes shift, beetles shift with them, blending into new patterns without disrupting the ecosystem. This gentle resilience links them to the ancient ancestors whose forms echo through time, connecting past species to those that walk quietly across forests today. Ancient beetle ancestors of modern species existed long before flowering plants, mammals, or birds transformed Earth's landscapes. These early beetles roamed prehistoric forests filled with towering ferns, giant horsetails, and dense mats of moss. Fossils show that many shared the same characteristic body shape seen today: a tough exoskeleton, segmented legs, and hardened wing covers. Their survival strategies were already in place, feeding on decaying vegetation, burrowing into damp wood, and relying on simple chemical cues to navigate. As continents shifted and climates cooled or warmed, these ancestral lineages split into countless forms. Some adapted to deserts, others to wetlands or alpine soil. Modern beetles carry echoes of these ancestors in their structures and behaviors, small living windows into eras long vanished. And through that lineage emerged the calm strategy of being small yet resilient, a trait that anchors beetles firmly in nearly every environment on Earth. The calm strategy of being small yet resilient allows beetles to endure conditions that overwhelm larger, more complex creatures. Their size helps them slip into microhabitats where moisture, temperature, and safety remain stable, thin soil layers. hollow twigs, curled leaves, or pockets beneath bark. Small bodies require fewer resources, so beetles can survive on sparse food during lean seasons. Their exoskeletons provide robust protection relative to their size, minimizing water loss and shielding them from predators. Remaining small also reduces competition, allowing beetles to occupy countless ecological roles without needing to dominate. This understated approach to survival has allowed them to persist through mass extinctions and environmental upheavals. And while they navigate these tiny spaces, their collective work gently reshapes the world around them, preparing forests for renewal in ways that often go unnoticed. Forests reshaped gently by beetle activity illustrate the profound influence small creatures can have on vast ecosystems. Beetles break down fallen logs, aerate soil, disperse fungal spores, and recycle nutrients that trees rely on for growth. Wood-boring species carve tunnels that allow moisture and microorganisms to penetrate deep into dead trunks, speeding decomposition. Leaf beetles prune plant tissues, influencing growth patterns and food webs. Ground beetles regulate populations of other insects, maintaining ecological balance without noise or chaos. Over centuries, these subtle interactions shape soil composition, forest structure, and habitat availability. Each beetle movement, chewing, burrowing, feeding, resting, contributes a small shift in the forest's ongoing evolution. And as these countless tiny actions accumulate, they create landscapes that feel alive, interconnected, and continuously renewed, completing this quiet chapter of ancient adaptations. Rain beads rolling off beetle shells reveal the quiet elegance of their protective design. When raindrops fall through the forest canopy, each drop lands on the beetle's curved exoskeleton and instantly breaks into smaller beads. These droplets gather briefly, trembling like tiny crystals, before rolling away in smooth paths guided by microscopic ridges on the shell. The beetle hardly notices the rain. Its body remains dry beneath this delicate choreography of water. Even during heavy showers, the droplets slide off quickly, leaving the surface polished and gleaming. Sunlight filtering through clouds sometimes catches these rolling beads, creating short-lived sparks of brightness across the beetle's back. This moment emphasizes how deeply adapted beetles are to wet environments, preparing the way for the next layer of understanding: the hydrophobic surfaces that keep beetles dry, even in the softest or heaviest rain. How hydrophobic surfaces keep beetles dry involves a combination of chemistry and textured architecture. The outer cuticle contains waxy molecules that repel water, preventing droplets from spreading or soaking into the surface. On top of this wax layer, tiny bumps and grooves create a microtexture that reduces the contact area between shell and water. This combination mimics what scientists call the lotus effect, seen in plants that never seem to get wet. For beetles, this water-repelling system offers protection from mold, parasites, and sudden changes in temperature. Water slides off effortlessly, carrying dust and debris with it, cleaning the surface as it moves. This self-cleaning action keeps the beetle light and agile, ready for exploration, sometimes even through small forest ponds, where soft ripples and gentle currents guide their movements. Beetles, navigating soft forest ponds, move with a calm confidence shaped by their light bodies and precise leg motions. Some species skim across the water's surface, using surface tension to support their weight like natural water striders. Others walk at the edges, where mud is firm enough to hold them, yet moist enough to cool their bodies. The pond becomes a slow-moving world of reflections, drifting leaves, and tiny currents that carry faint scents from nearby plants. Beetles approach water carefully, sensing vibrations and adjusting their paths to avoid predators hiding beneath the surface. Their movements create gentle ripples that expand outward, before fading into stillness. These calm journeys across ponds lead naturally to the more specialized swimmers, aquatic beetles that glide below the surface while carrying air bubbles for breathing. Aquatic beetles carrying air bubbles use a remarkable adaptation that allows them to explore underwater spaces for long periods. Before diving, the beetle traps a glistening bubble of air beneath its wings or along fine hairs on its abdomen. This bubble acts like an external lung, exchanging oxygen with surrounding water through diffusion. As the beetle moves, the bubble shines like a silver mirror, reflecting the world above. Underwater plants sway gently around it, creating shifting patterns across the bubble's surface. These beetles swim with coordinated strokes, gliding smoothly among submerged stems and drifting sediments. The air they carry gradually diminishes, but the bubble's surface remains bright until the final moments of their dive. When they return to the surface, droplets cling to their shells, droplets that catch and bend light in beautiful ways, setting the stage for the refractive patterns that follow. Light refracting through droplets on shells creates miniature rainbows that glide across a beetle's body. When water beads settle after rain or rising humidity, each droplet acts like a tiny lens. Sunlight passing through these lenses scatters into soft colors, pale blues, faint greens, and warm golds that shimmer as the beetle moves. The curvature of the droplet and the structure of the shell beneath it shape these colors into dynamic patterns that appear and disappear with each shift in angle. This refracted light not only beautifies the beetle, but also helps scatter brightness in ways that blend its silhouette into the forest's patchy light. The effect is temporary, fading as droplets evaporate or roll away. Yet, during those brief moments, the beetle becomes a moving constellation of color. These glimmers invite the eye deeper into the forest's wet, shimmering world, shaped by water, rain, and the softest elements. Raindrop rhythms guiding beetle movement create a gentle soundtrack that shapes how these insects travel through the forest. When rain begins, each drop strikes leaves, bark, and soil in distinct patterns. Beetles sense these vibrations through their legs and antennae, interpreting them as cues about shelter, moisture, and potential danger. Light rain encourages exploration. Heavier rainfall prompts them to move beneath logs or moss. The forest floor becomes a landscape dotted with tiny ripples and softened sounds, each one guiding the beetle toward drier paths or safer terrain. Raindrops also influence scent dispersion, helping beetles follow chemical trails more clearly. As the rain slows, these rhythms fade into a quieter pulse, and beetles respond by emerging again with renewed confidence. This shift in sound and moisture prepares the forest for nights when hidden species awaken under the soft veil of lingering humidity. Moist nights awakening hidden species reveal an entirely different forest, one that thrives when darkness and dampness settle together. Many beetles remain tucked away during dry daylight hours, conserving energy and avoiding predators. But when nightfall combines with lingering moisture, their bodies absorb the cool dampness that signals ideal foraging conditions. Leaves glisten, soil softens, and scents become richer as humidity gathers in the air. These changes awaken beetles that rarely appear during the day, each emerging from bark crevices, moss beds, or the undersides of stones. Their movements are slow and deliberate, shaped by the calm atmosphere. Moist air enhances chemical trails, making navigation easier. Small droplets cling to their shells, adding faint reflections that shimmer under moonlight. As these hidden species roam, they create a hushed tapestry of movement woven through the forest, an activity that fades gently into the quiet calm that follows every rainfall. The quiet calm after rainfall in the forest is marked by softened sounds and a subtle heaviness in the air. Water-drenched leaves no longer rustle. Soil absorbs footsteps without resistance. Beetles emerge cautiously, testing the environment with their antennae as the last droplets fall from overhead branches. The forest feels newly washed, carrying the earthy scent of wet bark and refreshed moss. Puddles form reflective pools that mirror the muted sky, while faint mist clings to low vegetation. In this stillness, beetles move with unhurried grace, exploring surfaces glistening with moisture. Microorganisms in the soil become more active, releasing chemical cues that draw beetles toward nutrient-rich areas. This post-rain calm provides ideal conditions for feeding and movement. As the air gradually warms, openings in the canopy allow light to reach these puddles, where water beetles begin drifting beneath lily pads in serene, flowing motions. Water beetles drifting beneath lily pads navigate a tranquil underwater realm shaped by filtered light and gentle currents. Lily pads act as floating roofs, casting cool shadows that protect beetles from predators above. Beneath these broad leaves, the water is calm, allowing beetles to glide smoothly, using synchronized leg strokes. Their streamlined bodies reduce drag, letting them slip easily between stems and submerged roots. Air bubbles clinging to nearby plants shimmer like tiny lanterns, guiding their path. These beetles rely on stored air or thin films around their bodies, enabling them to breathe while diving. The quiet world beneath the lily pads contrasts with the activity on the surface, offering safety and stillness. As they move, ripples spread outward in delicate arcs that fade quickly. Through this serene journey, the beetles contribute to the peaceful floating of surface beetles gliding across still water. The peaceful floating of surface beetles showcases a unique mastery of water tension. These beetles rest and travel along the water's surface, supported by microscopic hairs on their legs and bodies that repel water and prevent sinking. Each movement sends gentle vibrations across the pond, forming circular ripples that drift outward like soft echoes. Sunlight reflects off the surface, creating shifting patterns that dance around the beetle's silhouette. Their navigation depends on subtle leg motions, allowing precise control without breaking the water's fragile film. Surface beetles feed on tiny insects, pollen, or organic matter trapped at the top layer, contributing to the pond's delicate balance. The calmness of their floating mirrors the still atmosphere around them, air thick with moisture, plants bowed with rain, and reflections stretching across the water's mirror-like sheen. In this tranquil setting, their presence brings closure to the soft, water-shaped chapter of beetle life. Chemical messages drifting through air form an invisible language that beetles use to understand their surroundings. These messages, known as pheromones and volatile plant compounds, are released in tiny quantities by beetles, fungi, leaves, or decaying wood. Each molecule carries specific information directions to food, warnings about danger, or invitations for mating. As these chemical signals disperse, they follow subtle currents shaped by temperature and humidity. Beetles detect them with astonishing precision, even at low concentrations. The forest becomes a soft, scented map, guiding movement with trails the eye cannot see. These drifting signals weave gently among moss, bark, and soil, creating a network of communication that remains peaceful and steady. And when chemical cues alone are not enough, beetles add another layer of expression, soft tapping signals that travel through the surfaces they walk on. Soft tapping signals between beetles occur when individuals communicate by rhythmically striking their bodies or jaws against wood, leaves, or soil. These taps create faint vibrations that travel through the substrate, reaching other beetles nearby. Each tapping pattern conveys a different message: location, readiness to mate, territorial presence, or distress. The sound is too subtle for most creatures to detect, blending into the forest's natural hum. Beetles time their taps carefully, allowing pauses that make the rhythm easier to interpret. This quiet percussion functions like a hidden code, connecting individuals without revealing their presence to predators. As night settles and humidity rises, tapping becomes even more effective, traveling farther through softened surfaces. These soft rhythms help form evening pheromone clouds, another silent layer of beetle communication that expands as the forest cools. Evening pheromone clouds in the forest form when beetles release chemical signals into air thickened by nightfall. As temperatures drop and moisture rises, the atmosphere becomes dense enough to hold pheromones close to the ground, allowing them to drift slowly through undergrowth. These clouds are invisible but powerful, carrying messages about mating availability, food sources, or group gathering points. Beetles follow these chemical plumes with steady movements, adjusting direction as concentrations change. The forest at dusk becomes a gentle maze of scented currents, weaving between tree trunks and moss beds. Moonlight filters through the canopy, illuminating the pathways where beetles move along these signals. When pheromone clouds fade or fragment, beetles turn to another reliable method: vibrational communication through the wood and soil beneath their feet. Vibrational communication through wood allows beetles to speak in a language shaped by touch rather than sound. When a beetle taps or scratches the surface of a log, the resulting vibrations travel efficiently through dense wood fibers. Other beetles detect these signals with specialized sensors in their legs, interpreting the patterns as warnings, invitations, or directional cues. Different species develop distinct frequencies and rhythms, creating variations that help individuals identify one another. This method works especially well in dark or cluttered environments where sight and smell may be limited. Vibrations move smoothly through wood, bypassing obstacles that block airborne signals. These silent waves provide clarity in moments when the forest grows still. And within this stillness, beetles rely on their most delicate sensing tool, the gentle antennae that help them listen to the world through the faintest cues. How beetles listen with gentle antennae reflects their extraordinary sensitivity to the world around them. Each antenna is covered in tiny sensory hairs and pores that detect chemicals, humidity, temperature, and even microscopic particles carried on the breeze. These structures act like flexible receivers, bending slightly as air moves past. When chemical signals drift by, the antennae capture them. When vibrations travel through the air or substrate, the antennae register the subtle shifts. Beetles move their antennae constantly, sweeping them in soft arcs to gather information from every direction. This delicate scanning helps them locate food, identify mates, avoid danger, and navigate complex terrain. In darkness, the antennae become their primary guidance system, reading the environment like fingertips sliding across textured surfaces. These gentle listening tools guide beetles into deeper forms of quiet communication, continuing the silent conversation threaded through the forest. Hidden dialogues beneath the forest floor unfold in a world where sound travels not through air, but through soil, roots, and decaying wood. Beetles living underground communicate with tiny vibrations created by tapping, shifting, or scraping their bodies against the earth. These signals move easily through damp soil, reaching nearby beetles who interpret them through sensitive leg receptors. Chemical messages also drift through narrow air pockets between particles of dirt, carrying information about food, moisture, or safe passageways. Fungi, roots, and microorganisms contribute their own cues, forming an intricate underground network of guidance that beetles quietly follow. This hidden layer of communication remains unseen but constant, linking individual movements into a slow, coordinated rhythm. And when beetles rise from the soil at night, These muted conversations transform into something more visible, a set of quiet courtship dances performed gently under moonlight. Quiet courtship dances under moonlight begin with slow, deliberate movements shaped by instinct and subtle cues carried on the night air. Male beetles often initiate the ritual by approaching a potential mate with a low posture, their antennae tracing soft lines in the darkness. They circle gently, tapping or brushing the ground to announce their presence without alarming predators. Females respond with small shifts of their bodies, adjusting position to signal interest or neutrality. Moonlight filtering through leaves casts pale highlights along their shells, turning each step into a shimmering sequence. These dances are unhurried, designed as much for assessment as attraction. Chemical signals drift between them, guiding the pace and direction of the interaction. When the moment is right, the dance narrows into closer contact. And sometimes, this closeness produces an almost imperceptible phenomenon, shell rubbing, that creates sound too soft for most creatures to hear. Shell rubbing that makes barely audible sound happens when two beetles brush their hardened elytra together in gentle, rhythmic motion. These sounds are not loud or sharp. They resemble tiny rasps or whispers, carried only a short distance. Scientists believe these subtle noises help signal courtship readiness or territory boundaries, adding another layer to beetle communication. The texture of the shell determines the quality of the sound. The smooth surfaces produce soft glides, while ridged shells create faint vibrations. Under moonlight or inside dark logs, these sounds become part of the intimate atmosphere of beetle interaction. Each rubbing motion is calm and measured, guided by instinct rather than urgency. After this exchange, beetles often move apart or continue exploring, relying again on the deeper clarity of their senses. And in these moments, the sensory calm of beetle navigation becomes especially noticeable. The sensory calm of beetle navigation emerges from their reliance on simple, steady cues rather than complex thought. Beetles use antennae to read chemical trails, legs to sense vibrations, and eyes attuned to dim light to detect shapes and movement. This combination creates a navigation system built on softness, slow scanning, gentle turning, and patient adjustments. Instead of rushing, they pause when signals weaken, waiting for cues to strengthen before moving again. Their bodies interpret temperature changes, humidity patterns, and subtle gradients of scent, weaving all these elements into a quiet, continuous flow of information. The forest at night supports this calm navigation. Sounds fade, breezes slow, and shadows deepen, allowing beetles to travel without disturbance. This peaceful perception is part of a broader pattern, one shaped by the secret languages of slow-moving creatures. Secret languages of slow-moving creatures develop in environments where silence is safer than sound. Beetles rely on chemical cues, soft taps, subtle vibrations, and faint shell brushing to share information without revealing themselves to predators. These languages are layered, overlapping, and highly specific. Each species produces its own blend of scents, rhythms, and gestures. Over millions of years, these systems evolved not for speed, but for precision and calm survival. The forest supports this quiet communication with thick moss, dense bark, and soil that transmits vibrations gently. As beetles move through these habitats, their signals blend into the natural background, forming a dialogue that rarely reaches human awareness. This slow, hidden communication helps them find mates, avoid danger, locate food, and maintain social order. With this final whisper of connection, the chapter of soundless signals drifts naturally into the next realm of beetle life. Beetle eyes reflecting fractured light reveal how intricately these creatures perceive their surroundings. Their compound eyes are made of many tiny lenses, each capturing a slightly different angle of the world. When sunlight passes through the forest canopy and touches these lenses, it breaks into shimmering fragments, glints of silver, soft greens, or pale gold that shift with every movement. Beetles do not see sharp detail, but they sense motion exquisitely, detecting even the smallest flicker of shadow or brightness. This fractured vision helps them avoid predators and navigate complex environments without strain. The world appears to them as a mosaic of shifting tones rather than clear edges, creating a gentle, impressionistic landscape. As beetles climb, bark, or move across leaves, these fractured reflections dance softly across their eyes, guiding each step. And as they ascend, their tiny claws begin gripping the textured surfaces beneath them, leading to another quiet layer of beetle life. Tiny claws holding onto bark textures allow beetles to move confidently across rough or vertical surfaces. Each claw is curved, sharp enough to grip, but delicate enough not to damage the bark. When a beetle climbs, its claws hook into tiny ridges and grooves, creating secure contact points that support its weight. The pads beneath the claws contain adhesive structures that enhance grip through microscopic hairs. These adaptations let beetles walk upside down, cling during strong breezes, and explore the uneven worlds of trunks and branches. As they move, they read the texture beneath them, feeling humidity, hardness, and vibration through each step. Bark becomes a map filled with hints about food, shelter, and hidden pathways. And while they cling to these surfaces, their bodies continue the most basic rhythm of life, breathing through spiracles that open and close in slow, steady patterns. Spiracles breathing in slow patterns highlight how beetles manage oxygen quietly and efficiently. Spiracles are small openings along the abdomen and thorax that lead to internal tubes called tracheae. Instead of lungs, beetles rely on direct air diffusion through this network, allowing oxygen to reach tissues with minimal energy. These spiracles open and close rhythmically, sometimes synchronizing with body movements, sometimes slowing almost to stillness when the beetle rests. Humidity, temperature, and activity level all influence this breathing rhythm. In calm environments beneath logs, inside moss, or under gentle leaves, their breathing becomes soft and even, contributing to their ability to remain motionless for long periods. If danger or activity increases, spiracle movements quicken, just slightly. This quiet respiratory system supports their sensory awareness, especially the antennae that sweep through the air in soft arcs, gathering information with each breath. Antennae feeling the world in soft arcs serve as some of the beetle's most refined sensory tools. Each antenna is segmented and flexible, moving like a pair of delicate arms exploring the environment. The surface is lined with sensory hairs that detect scents, temperature changes, humidity levels, and even tiny air movements. Beetles sweep their antennae forward, sideways, and upward, tracing gentle curves that reveal the character of the world around them. These arcs help them locate food, identify mates, avoid predators, and orient themselves within complex habitats. The movements are smooth and deliberate, never rushed. As antennae glide across surfaces or through air, they accumulate microscopic particles, bits of soil, pollen, and forest dust. Some of this dust settles on the beetle's shell, shimmering faintly under light and carrying the story of its journey. Dust grains shimmering on beetle shells create a soft glow that highlights the fine contours of their bodies. These dust particles cling lightly to microscopic ridges and textures, forming tiny speckles that catch sunlight or moonlight. When a beetle moves, the dust shifts, revealing patterns of color beneath subtle greens, deep browns, or metallic blues shaped by the shell's structure. Dust can come from soil, pollen, bark, or even fungal spores drifting through calm forest air. As it settles, it softens the beetle's appearance, blending it more seamlessly into its surroundings and enhancing camouflage. Sometimes, the dust even carries chemical cues that other beetles can detect. With every step, the shimmer changes, creating a moving constellation of fine particles that trace the beetle's path. And beyond this delicate dusting lies another world of micro-details waiting to be explored in the next gentle fact. Patterns hidden in microscopic ridges cover a beetle's shell, like secret maps etched by time. These ridges are so small that they blend seamlessly into the shell's surface. Yet, under magnification, they reveal organized waves, spirals, and lattices. Light interacts with these structures in subtle ways, creating hints of iridescence or soft matte finishes depending on spacing and angle. The patterns help repel water, reflect heat, and strengthen the exoskeleton without adding weight. Each species carries its own arrangement, shaped by environment and evolutionary history. Some ridges scatter light into faint blues. Others create textures that mimic bark or leaf surfaces for camouflage. These microscopic landscapes guide how dust settles, how moisture moves, and how colors appear in different lighting. And as one looks closer at these tiny structures, the delicate symmetry of beetle forms becomes even more apparent. The delicate symmetry of beetle forms begins with their basic body plan: head, thorax, abdomen arranged in balanced proportions that support both strength and flexibility. Elytra cover the wings like matching shields, aligned perfectly along a central seam. Legs extend in mirrored pairs, allowing smooth, coordinated movement. Even antennae often show symmetrical branching or segmentation, helping the beetle sense its environment with equal precision on both sides. This symmetry is not rigid but softly expressed, shaped by curves and natural variation. It offers stability when walking, climbing, or burrowing. Forest light highlights this balance, casting even shadows across the beetle's form as it moves calmly from one surface to another. Eventually, their symmetry guides them toward resting places where they blend naturally, such as cool stones that offer a moment of stillness. Beetles resting motionless on cool stones create moments of quiet equilibrium within the forest. The stone's surface provides a stable, temperature-regulated platform that draws heat away from the beetle's body, slowing metabolism and conserving energy. In this stillness, the beetle becomes almost indistinguishable from its surroundings, its earthy tones matching the mineral shades beneath it. Moisture rising from the stone softens the air around the beetle, easing respiration through its spiracles. This pause helps recalibrate senses dulled by movement. Antennae lower slightly, legs relax, and the body settles into a posture of complete calm. In this gentle rest, internal mechanisms shift into slower rhythms, including the tiny muscles that control each shell plate with precision. How tiny muscles control shell plates reveals the remarkable engineering inside a beetle's compact body. Beneath the rigid exoskeleton is a network of muscles anchored to internal ridges. These muscles pull, lift, and adjust the shell plates with careful coordination. When a beetle opens its elytra to prepare for flight, these muscles guide the motion in controlled arcs, preventing damage to delicate wings folded beneath. During walking or burrowing, they stabilize the thorax and abdomen, distributing force evenly. The movements are small but strong, requiring little energy thanks to efficient leverage systems. Each contraction shifts the shell subtly, adapting to pressure, obstacles, or environmental cues. Together, these tiny motions shape the soft architecture of beetle bodies, where strength and flexibility exist side by side. The soft architecture of beetle bodies combines rigid protection with gentle adaptability. Their exoskeleton forms a durable outer frame. Yet beneath it lies a world of tissues, tracheae, muscles, and sensory organs, arranged in elegant harmony. Flexible joints connect shell segments, allowing fluid movement without compromising defense. Internal structures follow curved pathways that distribute force evenly, preventing breakage when beetles squeeze through narrow spaces or navigate rough terrain. Even the respiratory system, a network of air-filled tubes, fits perfectly within this architecture, enabling quiet breathing without expanding or contracting the body. The softness comes not from weakness, but from efficient design, where every part supports another. This architecture allows beetles to thrive in microhabitats that shift, twist, and compress. With this final detail, the exploration of micro-worlds blends naturally into the next chapter of gentle beetle life. Night beetles gliding under quiet stars move through a world softened by darkness and cooled by falling air. As daylight fades, beetles with nocturnal habits take flight, their wings opening with slow, steady confidence. The night sky becomes a vast canopy beneath which they drift silently, weaving between branches that sway almost imperceptibly. Cooler temperatures thicken scents, allowing beetles to follow chemical trails with greater accuracy. Their bodies reflect faint starlight in gentle highlights, tiny silver arcs moving through the air. The forest beneath them settles into its nighttime rhythm, leaves barely rustling, soil exhaling stored moisture. These night flights conserve energy and help beetles avoid predators active during the day. And when they glide near open spaces, the moon often lifts over the canopy, catching soft wing beats that shimmer in pale light. Moonlight catching soft wing beats creates delicate flashes as beetles pass through scattered beams of silver. Their wings, thin and translucent, respond to lunar brightness with a gentle glow that appears and fades with each movement. These wing beats are quiet, producing only the faintest hum, easily lost beneath the sound of drifting leaves or distant water. Moonlight enhances navigation, offering soft shadows that guide beetles around branches and across open paths. The cooler air of nighttime stabilizes their flight, allowing longer glides without fatigue. As they move, patterns of shifting light ripple across their bodies, like small constellations darting through the undergrowth. These shimmering moments blend seamlessly into the deeper quiet of the forest, where beetle activity influences the stillness itself, shaping a calm atmosphere that feels both alive and deeply restful. Forest stillness, shaped by beetle activity, may seem surprising, yet these tiny creatures influence the nighttime calm more than most observers realize. Their movements stir microcurrents of air, redistribute fine particles, and release soft chemical cues that other forest residents respond to. Beetles feeding quietly within bark or leaf litter help settle the environment, creating predictable rhythms that echo through the undergrowth. Their presence reduces sudden bursts of activity, as many nocturnal animals adjust their own patterns around the beetles' steady pace. Soil layers shift subtly beneath their feet, releasing faint, earthy scents that thicken nighttime air. This overall moderation contributes to the forest's deep, layered silence. And within this calm, beetles often rely on gentle cues from above, subtle starlight patterns that guide them with surprising precision. Beetles, navigating by starlight patterns, rely on light-sensitive eyes tuned to the faintest contrasts. While they cannot see stars as sharply as humans do, they detect brightness gradients across the sky, allowing them to move in consistent directions, even on moonless nights. This ability mirrors that of some desert insects, who use celestial cues for orientation. In forests, gaps in the canopy act like windows to the night sky, letting starlight fall in narrow beams across trunks and soil. Beetles sense these gradients and adjust their paths accordingly, tracing lines of faint illumination. Combined with chemical trails and temperature cues, starlight becomes part of an integrated navigation system. As beetles follow these subtle patterns, their movements add to the nighttime hush, a quiet shaped not by absence, but by gentle, purposeful motion. The hush of nocturnal beetle movement settles over the forest like a second layer of darkness. Each step, wingbeat, or shift of antennae occurs in near silence, blending into the soft tapestry of nighttime sounds. Leaves absorb small impacts, moss muffles footfalls, and cool air carries vibrations only short distances. Beetles move with patience, pausing often to taste the air or read chemical trails. Their calm progress reduces disturbance, allowing other nocturnal animals to move peacefully around them. This hush is not emptiness, it is a collection of tiny actions, so quiet they merge into the overall stillness. As beetles advance through leaf litter or drift through cool air, they create a gentle continuity that anchors the night's rhythm. And through this quiet movement, the forest deepens into a state of profound rest. Night beetles, gliding under quiet stars, move through a world softened by darkness and cooled by falling air. As daylight fades, beetles with nocturnal habits take flight, their wings opening with slow, steady confidence. The night sky becomes a vast canopy beneath which they drift silently, weaving between branches that sway almost imperceptibly. Cooler temperatures thicken scents, allowing beetles to follow chemical trails with greater accuracy. Their bodies reflect faint starlight in gentle highlights, tiny silver arcs moving through the air. The forest beneath them settles into its nighttime rhythm, leaves barely rustling, soil exhaling stored moisture. These night flights conserve energy and help beetles avoid predators active during the day. And when they glide near open spaces, the moon often lifts over the canopy, catching soft wingbeats that shimmer in pale light. Moonlight catching soft wingbeats creates delicate flashes as beetles pass through scattered beams of silver. Their wings, thin and translucent, respond to lunar brightness with a gentle glow that appears and fades with each movement. These wingbeats are quiet, producing only the faintest hum, easily lost beneath the sound of drifting leaves or distant water. Moonlight enhances navigation, offering soft shadows that guide beetles around branches and across open paths. The cooler air of nighttime stabilizes their flight, allowing longer glides without fatigue. As they move, patterns of shifting light ripple across their bodies, like small constellations darting through the undergrowth. These shimmering moments blend seamlessly into the deeper quiet of the forest, where beetle activity influences the stillness itself, shaping a calm atmosphere that feels both alive and deeply restful. Forest stillness, shaped by beetle activity, may seem surprising, yet these tiny creatures influence the nighttime calm more than most observers realize. Their movements stir microcurrents of air, redistribute fine particles, and release soft chemical cues that other forest residents respond to. Beetles feeding quietly within bark or leaf litter help settle the environment, creating predictable rhythms that echo through the undergrowth. Their presence reduces sudden bursts of activity, as many nocturnal animals adjust their own patterns around the beetles' steady pace. Soil layers shift subtly beneath their feet, releasing faint earthy scents that thicken nighttime air. This overall moderation contributes to the forest's deep, layered silence. And within this calm, beetles often rely on gentle cues from above, subtle starlight patterns that guide them with surprising precision. Beetles navigating by starlight patterns rely on light-sensitive eyes tuned to the faintest contrasts. While they cannot see stars as sharply as humans do, they detect brightness gradients across the sky, allowing them to move in consistent directions even on moonless nights. This ability mirrors that of some desert insects, who use celestial cues for orientation. In forests, gaps in the canopy act like windows to the night sky, letting starlight fall in narrow beams across trunks and soil. Beetles sense these gradients and adjust their paths accordingly, tracing lines of faint illumination. Combined with chemical trails and temperature cues, starlight becomes part of an integrated navigation system. As beetles follow these subtle patterns, their movements add to the nighttime hush, a quiet shaped not by absence, but by gentle, purposeful motion. The hush of nocturnal beetle movement settles over the forest like a second layer of darkness. Each step, wing beat, or shift of antennae occurs in near silence, blending into the soft tapestry of nighttime sounds. Leaves absorb small impacts. Moss muffles footfalls, and cool air carries vibrations only short distances. Beetles move with patience, pausing often to taste the air or read chemical trails. Their calm progress reduces disturbance, allowing other nocturnal animals to move peacefully around them. This hush is not emptiness, it is a collection of tiny actions so quiet they merge into the overall stillness. As beetles advance through leaf litter or drift through cool air, they create a gentle continuity that anchors the night's rhythm. And through this quiet movement, the forest deepens into a state of profound rest. Cool night air slowing forest rhythms creates a kind of natural lullaby that affects every creature within the trees. As temperatures fall, molecules in the air move more slowly, dampening sound and thickening the atmosphere with a soft, heavy stillness. Beetles respond by reducing their activity, conserving energy as their bodies cool. Movements become deliberate rather than hurried. Antennae sweep more slowly, wings remain tucked beneath their elytra, and steps grow measured. Moisture condenses on leaves and bark, adding gentle weight that quiets even the faintest rustle. This slower pace shapes the nocturnal world, setting the stage for silhouettes that drift quietly across soft layers of shadow. The forest feels suspended, as if night itself is breathing in long, steady rhythms that guide every small life form. Silhouettes crossing soft layers of shadow create fleeting shapes that glide across the dim forest floor. When beetles move in this low light, their outlines blur into gentle forms, rounded, shifting, and nearly silent. Moonlight and starlight filter through tree canopies in thin beams, casting overlapping patches of brightness and gloom. Beetles navigate through these shifting patterns with ease, their dark forms merging into the layered shadows beneath them. Each silhouette moves with intention, tracing arcs across moss, stone, or fallen leaves. Predators rely heavily on motion, and these softened outlines protect beetles by making them almost invisible. As these shadows move, they signal the beginning of activity from other nocturnal inhabitants. Hidden species begin waking in the darkness, responding to cues carried through air and soil. Hidden species waking in the darkness emerge from crevices, moss beds, and soil chambers as the night deepens. Many of these beetles remain unseen during the day, relying on cool temperatures and high humidity for safe movement. Darkness protects them from diurnal predators and allows them to forage freely. These species carry subtle scents that blend into the night air, forming chemical trails others can detect. Some glow faintly with bioluminescent signals. Others communicate by soft vibrations beneath the ground. As they awaken, they slip into the calm nighttime ecosystem, adding small steps and gentle wing beats to the quiet soundscape. This nocturnal activity contributes to the sense that the forest itself is alive and breathing, an impression that becomes stronger as the environment settles into deep night rhythms. The night forest breathing around beetles is a metaphor made real by small atmospheric changes. As cool air settles, warm pockets rise from the ground, creating slow, swirling currents that resemble the forest exhaling. Moisture evaporates from soil and foliage, drifting upward like soft mist. These subtle movements help distribute scents, guiding beetles toward food, mates, or shelter. Trees release oxygen more steadily in the absence of harsh daytime heat, enriching the air with a crisp freshness. The beetles move within this breathing landscape, their bodies tuned to micro-changes in humidity and pressure. Each shift in the air carries a message, an invitation to explore, pause, or turn. And through these atmospheric signals, beetles contribute to the calm continuity that shapes night cycles. The calm continuity of beetle life through night cycles reveals how rhythmically these insects move through darkness. Their behaviors follow patterns shaped by temperature, humidity, and the gentle cues of celestial light. Beetles feed, mate, explore, and rest in sequences that repeat night after night, forming a stable presence in the forest's dynamic world. This continuity contributes to overall ecosystem balance, as beetles perform essential roles even while most creatures sleep. Their quiet motion supports decomposition, soil health, and nutrient cycling with unwavering regularity. As dawn approaches, beetles gradually retreat into hiding places, letting day-active species take their turn. The transition is seamless, a natural handoff between night and day. And within this repeating cycle, beetle life persists gently, linking each night to the next in an unbroken thread of calm existence. As we come to the end of our quiet walk through the world of beetles, let yourself settle even deeper into whatever comfort surrounds you now. You've traveled through forests bright with dew, through moss beds glowing with soft humidity, through nighttime air shaped by starlight and slow-moving wings. You've followed tiny footsteps across bark, felt the hush of cool air moving gently around the trees, and listened almost without realizing it to the hidden signals of one of Earth's oldest, most resilient lineages. Beetles live in a world built from details so small they almost disappear into the background. And yet those details hold entire ecosystems together with a calm, persistent strength. As you drift here at the end, notice how steady their presence feels. Beetles are not hurried creatures. They do not race through the world. They move in quiet arcs, reading chemical trails, following the subtle tilt of wind or the faint glow of moonlight. They remind us that the tiniest lives can unfold with extraordinary patience, shaped by rhythms the rest of the forest responds to without ever seeing their source. These insects have survived global changes, shifting continents, ancient storms, and long nights far colder than anything we experience. And still, they move gently across leaves and soil, carrying on a cycle that began millions of years before us. The forest around them works in harmony with their pace. When beetles slow, the forest slows too. When beetles begin to move at dusk, the air thickens with scent and possibility. When they settle beneath stones or drift under soft layers of shadow, the night becomes quieter, as if holding its breath. All these details create a living tapestry that continues whether we watch it or not. And somehow, simply listening to it, simply imagining it, brings peace to the mind. It reminds us that not everything in life demands speed or urgency. Some things thrive precisely because they remain small, steady, and calm. As you breathe now, let your body copy that rhythm. Let each inhale feel like a slow drift through cool air. Let each exhale feel like a beetle settling into warm moss. You don't need to carry anything from your day into this moment. You don't need to replay conversations, solve problems, or prepare for tomorrow. The world can wait. The forest in your mind is quiet. The air is soft, and each small detail you visited tonight has gently lifted the weight from your thoughts, just enough to let them float. Imagine the forest, One last time, not as a place full of movement, but as a vast stillness, bark textured with tiny ridges, stones cool beneath a resting shell, moss glowing with moisture. A single beetle gliding under starlight, wings catching fragments of moonlight that shimmer briefly before fading back into darkness. Everything is slow. Everything is peaceful. Everything is safe to leave behind for now. And as the forest settles, so can you. You've wandered through 100 gentle facts, each shaped to guide you deeper into calm. If you're still awake, that's completely fine. Your mind may already be drifting toward rest in its own natural way. If you're already half asleep, even better, let that feeling carry you the rest of the way. Without effort, without expectation, there's nothing left to do. No steps to follow, no facts to remember. Just let your breath soften, let your thoughts fade, and let the quiet continuity of the Beetle's world ease you into sleep. When you wake, if this brought you peace, calm, or comfort, you are always welcome to return and to subscribe, so the next journey will be waiting for you. For now, rest deeply, drift gently, and let the night carry you the rest of the way. Good night.